Hi guys, let's do this Leetcode 237 today. It seems like a low-hanging fruit. It has been characterized as easy, so let's assume that what they're saying is really true, and we will see if it is really easy. It's delete node in a linked list, and it says the problem description says write a function to delete a node, accept the tail. I wonder if there is a hint there. Accept the tail. Why? Why that exception for the tail? In a singly linked list, given only access to that node. So we are only given access to that node, meaning you are not given head pointer. I would assume that's what it means. And so when I started looking, I said, well, it has only one input coming in, which is just the node, and how I'm going to start walking the list. But then what he's saying is you're only given access to that node, no head. Head is not given to you. Your job is to basically delete a node. And the to make things easier for you, all you're given is that the tail, this node will not be the tail. So that means it's somewhere in the middle, and the example is had 4519 and node is 5, and it should become 419. Should become after calling a function. Okay, example 2 is again the 4. Okay, the node 1, so now it should become 459, and you are given the third node with value 1. The linked list should become 459. And then the nodes, it says, is the linked list will have at least 2 elements. All of the nodes values will be unique. The given nodes will not be the tail. These are all good hints. All the nodes will have unique values. That makes our job easier because we know that we will not have duplicate elements. So the linked list will have at least 2 elements. That's another good hint, because if you don't have at least 2 elements and the problem says that the tail is not given for you to delete, then we have a problem, right? So that cannot work. So all of the given node will not be the tail, and it will always be a valid node of the linked list. And do not return anything from your function. And it says the given node will not be the tail, and it will always be a valid node, meaning we are not being given some kind of a null pointer or something. So let's try to do this. I would do this in C, and if that's kind of a common lowest common denominator. If you could do it in C, you could do it in any language. So the pseudocode is almost you have to understand the problem in terms of the pseudocode. So let's do that. So let's start with a temporary pointer, and we would say that start calling it temp, which is kind of pretty self-explanatory. All right, so and we'll say temp is equal to node. So we will initialize temp to the node. Now what we will do is while temp, let's create another variable next, and then we will say the next. Okay, or maybe it would have been might be better if we had a pointer here, and then we say next equal to, I guess both are fine, but I guess I prefer this approach. So next equal to temp next. Now the approach that I'm taking here is, because we are not given the head, that means we cannot really mess with the pointer. So there's no way for us to basically actually make the node go away, in the sense that piece of memory that holds 5 here go away, because somebody is pointing to it and you're not able to modify that. You don't have a previous pointer, as you can see here. So all we can do is we can copy the values of the next to the previous, next to the, and then before the tail hits, we are done. We just set that pointer to null and it should be okay. So now we say uh, temp val equal to next val, right? So we are basically copying the next pointer's value in the current pointer. And only catch here is that when we copy, after we have done the copying, we should see if next is null. And if that is the case, so if we are here, suppose we have copied 9 to 1, so temp is pointing at 1 and next is pointing here. So we should see if the next is null. Then we know that the next node is the actually the tail node, and we need to get rid of that. So if next is null, then we can simply say break. And um, and here we might be able to say, oh, before we break, sorry, before I jump, I'm getting ahead of myself. If next is null, then we have to say temp next equal to null. Basically we want now temp to be the last node, and we just break at that point, and then we just free the next, because that's redundant information we don't need. We already copied it to the previous node. And here all we need to do to keep moving, advancing in our list, is to say temp equal to temp next. Yes, so it's while temp next, take the next pointer, copy the value of next to the current node, and if the next is null, basically the next is the last node, then we set temp next to null, make the current node as the last node. We just break out of it, we just free next. Otherwise, we just continue here, and then we move to the next pointer. So it's basically just walking through the list. It's all on. There's nothing. We are not doing any kind of double pointer or anything like that. We are not walking something and then walking another thing, this and that kind of thing. So it should be all right. Now let's try to run it. Cool. So that actually works. So now let's try to do a submit. And that works as well. So everything is looking good. This was an interesting problem to and not overly complicated, to basically figure out that how can I delete a node given only that node. And the approach I am taking is to basically copy the next is node value to the current node, and then ultimately delete the tail. So that is Leetcode 237. I guess it was 237. Let's see here. Yeah, 237. Interesting. And I would hope that this was kind of interesting exercise of brain cells this morning. And I hope to see you guys in the next videos. Until then, goodbye.